We will be starting off with monitoring your Java, Node.js, PHP, and .NET Core application. Also, we will be discussing on how to get started with the distributed tracing. Distributed tracing will be quite useful if your application is spread across multiple nodes. And in this session, we'll be discussing on how you can get started with the application performance monitoring in case if your application is spread across multiple nodes, how to configure those. We'll be discussing that. And the third part would be capturing the error traces, whichever is happening in your application, and find the slow SQL statements which is causing exception or causing high response time whilst somebody is trying to load the web page or performing some critical business transactions. And finally, how to set up the alerts for critical application KPIs. So this is what we'll be discussing on today. And this session will be a complete interactive session. So we have our expert panelists available to help you. Wherever you have any questions, feel free to type in the webinar chat panel and you can get immediate answer from our product experts. We are available to help you. Let's see the top 3 digital workforce challenges in monitoring your production web application. Let's take an example of a banking production application. So a specific website is accessed by different parts of the world, and it has been accessed by multiple persons in different time zone. So to maintain this application up and running, there are a lot of backend teams who spend day and nights effort to maintain this application, either of a new production code push or an infrastructure change or a database level change. This requires human efforts and the technical efforts from the specific teams who is handling this application, right? So as most of the IT teams were working remotely due to this pandemic, even post pandemic, most of the companies employees were working remotely. So the team who is on site is very less to maintain their application. So lack of on-site support is one of the challenge that the IT teams are facing. And let's see how to address those in the upcoming slides. And maintaining connectivity to remote sites. Let's assume that you have a data center in UK and monitoring is happening from US. So in that specific case, maintaining connectivity to the multiple data centers is definitely a challenge, which requires a significant amount of bandwidth consumption. Along with that, a frequent level of monitoring is required. And in fact, auditing is required to make sure that these applications and the employees were accessing the application or monitoring the application perfectly with the security compliance, as the security compliance plays a key role in the application performance monitoring. And managing the distributed application with remote teams. Multiple teams work with multiple monitoring tools. So it is quite challenging to gather the data from multiple tools and get an actionable insight from the data being monitored. So this is definitely a challenge. And let's see how ManageEngine Application Manager can help you to address these 3 common problems. And apart from that, we will be discussing on the additional problems that the IT teams are facing in terms of performance monitoring and how to address these with an automated application performance monitoring tool. Let's get started. Visibility into Java, Node.js, PHP, and .NET Core applications. So let's take a common DevOps scenario. So what the DevOps team does, right? DevOps team develop the application and they perform the operations part. That is, after developing the application, they take care of the maintenance and post support activities for the specific application. Say, for example, the team is getting a complaint from the end users saying that the application is slow and takes time to load. So the team has to immediately react and to fix the specific issue reported by the customer. So this has been again escalated to the server admin and then goes to IT manager, and all this involves a considerable amount of time, right? So this is a common scenario in the DevOps whenever an application performance issue rises. Let's see, before we get started with the solution perspective, the common reasons on why your application might be slow. There are multiple reasons your application might be slow. Your application is not a single component, right? Application is spread across multiple different entities. That is, application uses a database. Application has an Elasticsearch. Application has its own Redis component. Application uses a web server. It uses a load balancer. So all these components were tied together with each other to keep your application up and running. If any of these components goes down due to configuration issue, or due to an overload issue, or due to an user mislead issue, or due to a security bug, how to address these problems? Say a web server might be overloaded, or the load balancer might have been misconfigured to allocate the resource to a wrong virtual group. The memory usage, that is, maximum number of out of memory exceptions might happen in your web application, though the memory has been allocated uh, with a maximum way. So memory leak due to an inappropriate thread usage, and this needs to be addressed, right? And the poor app code might also result in the application performance issue. So whenever you try to scale up your applications, that's where most of the companies feel that their application inefficient codes were exposed outside, and that's where they try to optimize the application. Whenever you scale up your application, the most of inefficient codes will come up. So you can optimize these components by fine-tuning the DB calls and analyzing the method calls and web service calls. Let's see how the application manager can help you to address these common problems along with the advanced way of troubleshooting. The traditional application performance troubleshooting approach goes like this, wherein if a customer reports an issue, the developer or the application support team try to reproduce the issue from their end. Sometimes they may be able to reproduce the issue, sometimes they may not. So in that specific case, they try to analyze the logs from the application side. They try to analyze the application server logs, try to analyze the DB server logs, and all this requires a separate analysis from different components to find where exactly the issue has occurred. Because initially I have explained you that the application architecture is quite complex, as it is spread across multiple systems like Redis, Elasticsearch, and cloud components or third-party external APIs. To figure out where exactly the issue occurs, analysis of logs from multiple sources required, which is definitely a time-consuming task, right? And app code analysis is required if some exception is found. Say for example, you have found an null pointer exception in your Java application, and that requires you to analyze the code on why this null pointer exception has occurred, and requires you to analyze the stack trace to fix that issue, and then you build a fix. So this traditional model of application performance troubleshooting is definitely a time-consuming task, and there are key disadvantages like the mean time to time repair ratio is very high when this model is involved, and the end user experience is definitely impacted because the user will not wait for a long time, right? The customers will no longer wait if they're trying to perform a critical transaction, and if the website is not available, or if they're unable to perform any transaction, that's where the user gets irritated, and it becomes an escalation to the customers or to the stakeholders, and they are in high pressure to fix the issue within a short deadline. So this needs to be addressed with an efficient application performance monitoring solution. Let's get started for the modern approach. Hope this is interesting. The modern approach for maintaining your application performance is using the application manager APM insight. So let's quickly get started by diving into the GUI of Application Manager, and let's see the real-time usage. So here is the GUI of Application Manager. After installation of App Manager, here you can find a dedicated tab called APM Insight. APM stands for Application Performance Management. As it gives a deep level insight, it's APM Insight. And here you can find the applications whichever is being monitored, and we support Java, .NET, .NET Core, Node.js, PHP applications, and Ruby on Rails too. So these were the applications being supported, and this is a single point of dashboard for your multi-tier web environment. Not to be worried in case if your application is spread across multiple backend components, because we support monitoring the key components like Java, Node.js, PHP too. All you have to do is go to the downloads page, wherein when you scroll down, you can find the downloads page right here, and you can get started by installing the APM Insight agent on the application server. So depending upon the application manager version, you can download the agent from our web page. If anybody needs the download link, just reply back in the chat panel. We can help you to download this agent. And if you need any installation assistance for configuring in your environment, you can very well reach out to us and we will help you to get started. And here you can download the application agent based upon your requirements and get started with that. This agent needs to be installed on the application server where your web server is being deployed. So the agent needs to be installed in that specific machine where it talks with your web application and perform the application performance monitoring and push the data to the application manager web GUI, and from where you can view the data. So this is how it basically works. So let's get started with one of the Node.js application. So when you click the app name here, you can find the data being displayed here along with its last communicated time and the response time broken by the components. So here, this is the overall dashboard. This is a single pane of dashboard for your complete application performance monitoring. On the left-hand side, you can find the appdex, which actually indicates the application performance index score. This score ranges from 0 to 1. 1 indicates the highest level of application performance, and 0 indicates that the application is performing poor. So by analyzing this score, one can definitely understand how well the application is performing in a real-time perspective. And all this data is real-time. And you can find the average response time over here, throughput, request count, and exceptions. So the average response time indicates, say for example, a user is trying to access the web application by a web browser. They just hit the web browser for that specific URL, and this web browser makes a GET request to that specific URL, and this request is transferred to the application web server, and this data is being transferred in the form of ICMP packets, and this reaches the specific application server, and then the server acknowledges the data, and it two-way SSL communication happens, and then the web server responds back with the data being requested by the end user. So this is how the transaction is being carried in a very layman's perspective. So if there is any issue in the web server, right, the response time will be increased, throughput will be reduced, and the request count can be definitely be reduced, because if the web server is overloaded, then your application might not be able to perform as usual. So the exceptions count will be displayed right here, and the errors count as well. So request throughput, data throughput, that is the bytes in and bytes out happening in your application. The exceptions count, which includes the warning and fatal count, that is minimum, maximum, average, and 95th percentile value, overall the errors count, and the data throughput. Okay, this is the data being displayed right here, along with its split up by the exception components. Say, for example, if there is any exception happening, what type of exception is that? And you can find those information along with the top 5 transactions by its response time and the top 5 slow traces by its response time. So this will help you to analyze the transactions in your web application. Whichever is slow, you can view those in this dashboard itself, and you can find the exception traces along in this specific page. And the recent 5 error transactions too, with its transaction name and the exceptions count. As you could see that no class definition error has been the highest error count, which definitely needs to be fixed by modifying the jar files or adding an entry to the class whichever is missing. So this needs some developer attention. So this is how one can quickly troubleshoot from the basic dashboard. And let's quickly get started to the advanced level of troubleshooting by checking the other parameters. So before that, I'll take you to the slide and explain the other metrics. So drilling down into the transactions via distributed tracing. So the transactions can be classified into two. That is the distributed transactions and the normal transactions. The normal transaction is the one which is a direct reflection of the web server, which is directly being accessed by the user, which is a direct transaction. And if the transaction involves multiple nodes, that's where we treat as distributed tracing. If one transaction is happening in one of the primary node and that involves an transaction to the secondary node, so this kind of transaction involves a chain level of sub level of transactions, which requires a detailed monitoring. That's where the distributed tracing comes into picture. And let's see how it can help you in terms of monitoring. So with the help of distributed transaction tracing, you can focus on the execution flow. That is, one can understand the complete end user journey with the request flow across multiple applications. You can also track the application call using the distributed tracing. That is, this agent tries to add the HTTP header, right, with the metadata which is required to track the specific service request, which will help you to analyze the complete chain of the reactions with the detailed information on what exactly is happening. You can also track the transactions whichever is made from one application to another. Say, for example, in this picture, you can see that there is one transaction involved, which involves 4 method calls plus 5 SQLs. So we show you the delay time if there is any, inclusive time, and the exclusion time for those. You can refine the business transactions. That is, there are multiple transactions which could happen in your applications. Not all the transactions required monitoring. Only few key business applications or transaction requires an efficient level of monitoring. The other UAT application or minor level of transaction doesn't require efficient monitoring. In those cases, you can pinpoint few transactions as key and get the complete user experience so that you can delight the customers by giving them a very efficient services in terms of managing their application. So I'll take you to the GUI and show you how you can get started with that. So you can choose the transactions tab right here. And then you will find the various transactions being listed right here, which includes the AppDex score for each transactions, count, errors, and average response time, average bytes in and bytes out, and the key transactions too. So you can click a specific transaction. Say, for example, you may click this transaction and find what exactly is happening inside this app transaction. And you could find that the traces of this transaction and the response time, CPU time, external calls, exceptions count for this transaction, and the SQL time, and the distributed call count. So this transaction doesn't involve any distributed transactions because the application is being responded in a single node itself. But it's spread across multiple nodes, then you would find the distributed calls count right there. I can find those. And here you can sort it based on the slowest count, and you could also find the raw view to get data started. And response time broken by components, that is the web call, HTTP call, the minimum, maximum 95th percentile value, the application code value, that is the minimum, maximum, and 95th percentile, and the overall response time for this application, along with its request throughput, minimum, maximum, average, and data throughput, as I have initially explained, data throughput for this initial transaction. This would be quite helpful in terms of optimizing your transactions for an efficient network throughput. If keeping the network throughput in mind, one have to develop the applications, saying that it doesn't consume high amount of network bandwidth. So this is one of the key metric that the developers can keep in their mind while developing their applications. So app server component split up, and the split up by exceptions, event count, error count information will be shown right here. And if there is any background transactions, you can very well see those transactions right here. And you could see the transaction name, average response time for the same. You can very well configure the key transactions by just choosing the configure key transactions, and then all the key transactions will be displayed right here. You can choose the specific transaction, whichever you want to classify it as key transaction, and can get started with that. And if there is any error transactions, you can very well find it by just choosing the errors, and the transactions will be displayed right here. And you can see those transactions right here. Click on it to find the details. By this way, you can understand the complete customer experience for each and every transactions, optimize every transactions individually by analyzing the each front-end details. And if there is any web transactions, you can find it. There is a dedicated tab given here to find the key transactions. To ensure that you get a high level of details for the key transactions, we have given this. Let me switch back to the presentation and get started with the next topic. Capture the error traces and dive into slow SQL statements. So as we all know that the application is prone to issues, and we are either of these applications can be classified into two different type of exceptions. Am I right? Handled exceptions and unhandled exceptions. Handled exceptions is something that whenever the developers write a code for their application, they understand the user pattern. Based on that, they mark that if this is the input, accept it, and if this is not the input, then throw an issue. So this is an handled exceptions in the code level. However, there are many cases wherein multiple exceptions would occur in an unhandled way, where the developers were out of control of it. Say out of memory exceptions, which developer is not on not aware of on what whenever the user is performing an heavy load transaction, out of memory exception could occur, wherein the developer doesn't have control of it. Network level issues, network bandwidth. So these kind of statements needs to be identified, and developers tries to analyze this issue, and sometimes they try to connect to the database and find the issues by running the commands, right? To find the slow SQL statements, which is causing the slowness to your application. It requires deep level of understanding of the entire application architecture and SQL knowledge too. So let's see how the application manager APM insight gives the internal code level invocation for troubleshooting your web application from the root. We identify the slowest method calls, whichever is happening in your web application. That is, the web application is built in programmatically by combining multiple methods, multiple functions, multiple class. Okay, so if there is any method which is causing a backend breakage to any of the application functionality, that's where the issue occurs, and a method might be classified into slowest category if there is an backend query which is causing slowness inside the method. So how to identify that? So right from the GUI itself, we'll application manager show you the direct method and the direct SQL query which is causing the slowness, so that the developers no need to analyze the logs or stack trace or perform or spend high time is not required anymore, as this data is available in the GUI itself. So let's see the importance of thread profiling for the DevOps. So we saw how to understand the code level diagnostics, that is capturing the slow SQL statements and capturing slowest method calls and capturing the stack traces, whichever is causing application performance. Apart from this, thread profiling is important for DevOps. Say for example, if there is any application which is causing high CPU, you need to understand which specific thread or which specific code snippet is causing high CPU. So in that case, one can perform the thread profiling to get the invocation count of every method and find the time consuming methods from the GUI itself. So once this is done, you can get an complete insight into the problematic code. Say for an example, once this is identified, you can drill down to the trace details and find the exact methods sequence which is involved in this slowness and fix this issue from the root level by adding an caching or DB fine tuning, whichever is. So this is the next level of optimization that the developers can perform. So with this, I'll quickly switch back to the GUI of Application Manager and let's discuss about the components which we were discussing. Previously, we were discussed about understanding the business transactions, which is causing slowness to your applications, and finding the app score, error transactions, and distributed transactions by choosing this. Now let's see the DB calls which is happening in your web application. As we all know that every single call involves a DB operation also. Significant amount of operation is being happening in the DB to retrieve and data requested by the user. So there are cases that the DB might go down, or the response time from the DB is high if if the database is located in a isolated place or in a different DR. And there are cases that few queries might run multiple times, whichever is not required. Instead of the count can be reduced to reduce the application performance time, that is the reducing the response time. So this can be definitely performed by analyzing this data. That is, we show you the count, errors, average response time, the minimum response time, and max response time for the each and individual database operations right here. And you can find the table view also for this. And you can sort it based on the request count, average response time, total response time. So I was talking about finding and suspected trace, finding and suspected method or transaction which is causing slowness, and how to identify that. Application Manager gives you the data on the GUI itself. That is, you can find the specific transaction by just clicking that. If there is an error, a tag with an error along with its response code will be added to it. So it will be helpful for the users to identify. So you can see the summary along with its response time, CPU time, number of external calls, number of DB queries, whichever is involved in this transaction, memory used, slowest method calls, and count. So this level of information being shown, and this is the specific method which is causing slowness to your application, and the duration is so and so, and this is the backend query which is involved as a result of this method call. You can drill down to the next level by just choosing the trace details, and you can find the method calls, external calls, and SQLs right here, along with this delay time, inclusive and exclusive time, and the total information right here, along with its backend query and the sub method details as well. And you can find the SQL statements by just choosing this, and find the query start time, execution time, query, and number of queries being executed. And if this transaction involves any external calls, say for example, some application might bundle a third-party APIs. Say for example, a cloud telephony service provider API might be integrated, and SMS gateway API might be integrated to push any notifications from your application. If there is any latency in any of these APIs or any external calls, these can be easily identified by just choosing this remote external calls. And you can find the other traces in this transaction too by just choosing this. So this is how one can perform an efficient way of transactions monitoring, and can get these track traces for error transactions too. So here you can filter the error transaction, get those details, and if there is any distributed traces, you can find it right here, along with its start time, response time, external calls, and the exceptions count involved in this distributed traces, SQL time, average response time, distributed call count, and instance name. And if there is any error transaction, say for example, let's choose this, and you can find the trace details as I have mentioned for the same. And by just choosing this exceptions tab, you can actually find the transaction whichever is having an exceptions, and you can filter the exceptions data based upon this key filter as well, and can get this detail. And here is the recent 5 exception traces, you can find it, and the transaction splitter by its error code and error count, along with its warning and fatal. So fatal requires immediate attention, so you can filter those details right here and can get started with that. And then the service map is one of the key feature which will help you to identify how your application is built. It kinds of it builds an application architecture, that is, you use a PGSQL and a web server and an external API. Service map will help you to analyze these components and can show you the component statuses right here. That is, the application is up, DB is up. By choosing that, you can find when you do a mouse over, you can find the average response time of the database, throughput of your database, total request for, which is received by the database. So the service map would be quite handy for the developers to quickly understand the overall application behavior. So with this, I'll move to the app slide to discuss the other topic for today. So let's see what are the key essential skills needed among the IT teams post pandemic. So after pandemic, most of the companies, due to the government regulations, were still working from home, and major workforce is still remains to work from home. So This requires continuous collaboration with the multiple teams and continuous knowledge transfer of your applications, and gathering insights and sharing with the team is quite important to find the new issues, and sharing with the teams is required. So you have to be decisive and persistent using the data being monitored. As most of the teams use multiple tools, it is quite important to have a key understanding of the data. Instead of having in multiple tools for database monitoring and for application monitoring and for app monitoring, a single tool like APM Insight will help you to be decisive to make future allocation of the workload, and which will definitely help you to reduce the hardware or the software price spent, and you can definitely reduce the it will definitely help you to reduce the cost spent in the application performance monitoring. So the data driven decision would be quite helpful when using the reports which you gather from the APM Insight, and through which in fact you can get continuous reports, get in alarms, and perform proactive performance monitoring. So let's see how you can set up alerts for critical performance parameters. So as I was saying, you can get the application error based on its count from by the exceptions tab. And the key analysis of the historical application performance data is required. Say, for example, you need to analyze the historical data to find the response time of your application. Yesterday, how much before deploying the new code, how well your response time was there, and after deploying the code, how well the response time has increased or decreased, or monitoring your application during a high load, during an key transactions. So that is required during your production hours. And the app deck score, that is the single point of SLA for your application performance count. So you can find these historical application performance data right here from the GUI itself for all your applications being monitored. You can also streamline the alarms for the application performance. That is, this tool not only helps you to optimize or perform the monitoring, you can also send the alerts to any application via webhooks. You can also perform AWS or Azure based automation, get Slack notifications, and specific SQL jobs can be started, and which would be quite helpful for the DBS in terms of setting up the orchestration. So let's get started by switching back to the GUI, on let's discuss on how we can fetch the data and how the alarms can be configured for the key KPIs which is being monitored using the application manager APM Insight. So for all these application, whichever you are being monitoring, right? So those will be displayed right here in the APM Insight. Let me take one sample application right here. Let's take this. So when you choose the instance, you can find the configure alarms, using which you can configure your alarms, and all the key components will be displayed. Say, for example, you can choose admin, configure alarms, and you can choose the type. And here you can choose APM Insight. And here you can see the list of performance metrics. So you can configure alarms for these metrics, which includes the response time, AppDex, throughput, frustrated count, satisfied, tolerating, and CPU usage percentage for the application being monitored. So you can find these data right here. And you can perform n number of automation and orchestration activities, like sending an email and SMS is quite traditional, and performing an automation using the executed program That is, you can create whatever type of automation that you would like to achieve if an application performance issue is rising. You can create a script for that and using the execute program. Application manager, whenever it identifies your application issue, it tries to execute your script through which you can perform an, a complex level of automation. And it is capable of sending the SNMP traps. Cloud-based automation is possible and SQL job-based, and it's capable of sending the alerts via webhooks to any third-party applications too. So let me show you on how you can fetch the reports. When you choose the reports right here, in the application servers category, you'll find APM inside. So here you can find at a glance report, which will help you to find the application behavior. Here you can find the satisfied, tolerating, and frustrated count for all the key metrics. You can print this data, PDF, CSV, or automatically send this as an email. You can also get the attribute-wise report for your specific component, and the health of your servers can be automatically pulled as a report. So with almost we have come to the end of the session, and let me switch back to the presentation and discuss about the key takeaways from the today's session. So we have discussed on how you can monitor your production application and the tracking this application distributed transactions and thread profiling, historical application performance monitoring with an automation for cloud applications and containers too. Thank you.